we are on the steps here. The steps is usually a nice place to do this. All right, guys, it is time to get the motor installed in this thing. Depending on whether you're installing a motor or an engine, I'm going to actually go through with you 2 ways on how to do this, because you might want to do it differently depending on what your setup is. 2 tricks on how to perfectly center an engine coming up. All right, guys, we are on the steps here. The steps is usually a nice place to do this. We have the plane mounted vertically. Our motor assembly is just sitting on the firewall. So what we are going to do, you can use this to set depth if you want to make it a little easier, but we're also going to use it to center. This is a preferred method as long as you have a firewall where this stuff can sit. Place the motor on top of the firewall, and we're just going to go ahead and set our canopy on here nice and straight like that. And we are going to use a vernier caliper, and numbers aren't going to be important. All we're literally going to do is rotate this thing around, and we're going to make sure that our measurements are all the same in every direction. And when you have that set in every direction, and you know that that motor is centered where you want it, you're going to go ahead and leave the motor there. We are going to gently remove the cowl back off of there. Set that off to the side. And now you're going to take a pen and go ahead and mark all those center holes so you know exactly where you want to put this thing, and you're going to wind up with a perfectly centered engine. And as I said, once you have that, you can also then change your depth to make that perfect, just so that your spinner plate sits outside of your cowling. But one of the easier methods in order to center an engine, but depending on whether you're going with a motor or something else, you may have to use the other method that I'm going to show you. Let's get to it. All right, guys, it's time to get the motor installed in this thing, and I do mean motor. Motor is in an electric StinGR85 from HV Aviation and Mr. Jim Kit. So what I did here in the motor dome, since I'm flying blind, this does not match a DA50 or any other template that I have. So I need to make sure that I get an outline of this and then an outline of this thing, and I will transfer this outline onto that piece of paper. So I'll peel all this off now in one piece after I have it outlined, and I'll make sure that this template's perfectly centered in there, and I'll put it back, and then I know where to drill my holes. All right, there's our outline, so let's get that on some paper. So we're getting this lined up, and although that template works out, here's the first problem I run into with this. This motor assembly is all fairly close to the nose. So if you guys can see that as I get that thing to there, if I keep the weight distribution of the motor straight down towards the bottom, what happens is the motor itself with the small gear, the pinion if you will, rubs on that cowl. So you know, while we test fit, I'm going to have to turn this plate sideways almost in there in order to get this thing to go, even cant it down just a little bit. So you know, measure 14 times, cut once. That's what we're doing, because this plane is no longer in existence. We have no room for error. Check this out, guys. My boy Donnie Clark, he hooked me up again. He 3D printed me the cage. I gave him the idea, the dimensions, and the guy drew it up and he printed it for me. I need to mount my ESC and the airflow mounted underneath the motor. I want the airflow to come in through here and then exit, which I'll make the chin vents and stuff down through the bottom, the belly vents. But I want that airflow to roll over this. After this is installed, I'll show you why I designed it this way and the thought around it. But it's been what's been holding me up right now from getting this thing balanced and progressed with the install, because I have to determine battery placement once everything is kind of fastened and I know where it's going to go. So now that I have this, let's get this bad boy mounted up. Let's get the balance in this aircraft. And there you have it. There is the complete install of the StinGR85 with the Tribunus 2 130 amp ESC and the special made 3D cage. You could see how nice and clean that is. That's the way we like to roll, baby. So we have our power wires separated through a grommet that goes in through the motor box here. Our ESC, that lead ain't attached to nothing, but it's mounted through another grommet right there to protect it as it goes through the cowl. Our ESC is held in simply. We got one zip tie there for the cage, so that way there's no way that slides out. Our wires are held in there on the side. And the whole idea behind the cage of this ESC was to keep it mounted so the air is going to come through the front of the nose here, roll down through the motor box, and as you can see, I built standoffs in the cage. So this ESC will get airflow minimally obstructed all the way around this thing, and then it's going to flow out those spoiler vents down into the bottom out of the aircraft. So super clean install. Very happy with the way this looks and the way this turned out. Super stoked, super excited. We're getting closer. Love it. Well, the last couple days have been very frustrating for me, all because of trying to get the telemetry out of the Tribunus to carry itself over EX bus into the Jetty Duplex Rex 10 receiver, and that would be this wire that I have color coded blue. So with that being said, it's again been very challenging, and ultimately I got it worked out thanks to a guy that made a post on RC groups months and months ago. He had the same issue, and it turns out that there's 3 wire connections here. 3 ports. One says master, one says slave, and the other one says PC. The one that says PC is what you use to update or program your ESC, and you need a special diode cable in there to be able to program through the V-Link controller to communicate with this thing. But anyway, the master is what puts all the throttle information and power in. Secondary from the BEC, the way it's listed in the instructions, it makes you think that that comes out of the slave. It does not come out of the slave. Ultimately, it comes out of the PC port. So the PC port will give you your backup BEC as well as your XBus information, your protocol to speak telemetry, everything out of here about the motor, setup, temperature, RPM, milliamp usage, all of that stuff. So we got all that worked out, finally done, thanks to a lot of reading. Page 2478 in the RC group forums. Now we have everything set up. We're starting to put the final touches on where we're going to position everything in here. We have some holders for our AMOS 150 connectors through our cap pack. Our wiring will be secured in the side. We have to do some wire cleanup, but that's what's on the agenda here. Hopefully battery tray and carbon rods can go in today and position that. And short of that, then it's going to be rudder pull, and we're pretty close to finishing up this project. So let's get into the final details inside. This, by far, I think will be the most nerve-wracking part of this whole thing. This is a 25.5 length by 13 pitch Falcon prop that I purchased from Northwest RC. They were one of the only few that have it. It is a beautiful Falcon carbon fiber prop, super light, made for electric. And then I opted for the gas spinner, Falcon spinner, and I picked this up directly through Falcon. It's a 4.5 inch. This is embossed paint, so it is actually in with the carbon fiber when they mold it. It's not painted on the outside. And the nice part is that I never have to worry about putting a starter on there and getting this thing cranking. But we have to get this prop drilled, and there's a couple ways to go about doing it. You can just go ahead and do it just like this with the StinGR85, which you can just use the center bolt and go right through and tighten everything up. Or you can opt for 2 bolts in there, and then there's a spot in the front of the motor where you can actually screw in 2 studs. Let me show you what that looks like. So you would be able to actually thread in 2 of these little studs right here, and you can use 2 studs and 2 bolts. For the sake of trying to keep everything perfectly balanced, I think the decision has to be made that everything is going to be the same. And there's just something about, and it's probably perfectly fine, but it's just me not knowing because I don't have the diverse background of all this testing. I'm sure just the center bolt is fine, and I'm sure just 2 bolts with the 2 studs is fine, but I want to keep everything the same, and I probably need a little bit of nose weight anyway. So with this prop, I'm actually going to drill all 4 of those and put them in, as well as the center bolt. And the option there is going to be that everything is going to be balanced out weight-wise, and I never have to worry about just 1 bolt coming loose. Everything is going to be okay. And I'll do some research after we're done here to see maybe after we put those 4 in there, you don't even need the center bolt anymore. So that is an option, but I'm going to use this for a guide, and I have this thing laid out the way I want to in here. And the first thing I'm going to do, I got myself a brand new 4mm drill bit because I do not want a crappy drill bit drilling into the prop. You screw this up, you're out $200 easy. The prop's $100, the spinner's $100, and you're very quickly out some money. So we're going to go ahead, and I'm just going to drill a pilot. And I don't mean like a pilot hole, I'm just meaning a pilot mark to get started, so I know exactly where those are. I'm going to slide this to the end of the workbench and do it. We'll time lapse that, and then I'm going to take this over to the drill press, and I'm going to drill the prop all the way through. And then once the prop is done, I will go ahead and center mark, just like I did here, the back plate once I know that this is where I want it, and it would be centered in the spinner opening. Once I have that all set, then we'll go ahead and drill this back plate last. But you know, like I said, they give you a couple different options here from HV Aviation with this motor, and I'm sure they all work fine. It just comes down to me, security and personal preference. So we're going to opt to drill this thing out. And here you can see I went ahead and drilled my marks, so I know where I'm going to be drilling with these things. I'm actually going to take a smaller bit now and just start a pilot in there so I know that I'm centered and ready to go. You can also use a punch awl here. And I opted to put the pattern this way, not this way, because if you turned it and put one here, I just look at that as more potential if, you know, something could happen or weaken or flex there. Not like I think it would, but again, just being cautious. I'd rather them this way than both of those screw holes right on one blade where it might seem to be easier to fracture it. So we're going to go ahead and drill 2 small pilots on there, and then we're going to get going. Drilling. So hopefully you guys got to see what I did there. As I drilled my prop, I used just the center bolt, positioned it where I wanted it on my small pilots, drilled 1 hole, added a bolt, drilled another hole, added another bolt, and another bolt, and another bolt as I drilled. So I know everything fits and it's okay. Again, 4mm holes right there. And it does say in the directions you can open those up to 5 if you need a little bit of wiggle room. Then I went ahead and made sure that this thing is here. And on this engine, I don't have to worry about indexing it for the flip because it's a motor and it's going to stop anywhere it feels like it. And what I did here is I positioned it so the prop was even in the opening of my spinner. And once everything was lined up, I drilled one mark. And I'm going to take this over to my drill press, my bench press, and we're going to drill that one hole, and then we're going to put the bolt in there with the center, and we're going to drill another and another and another, and we're going to walk our way back around, so that way we know that everything is lined up here. So there's our fit. You could see the spacing around our spinner. We fought with it a little bit, had to clean out them holes, and we went up going to the 5 millimeters just to give me the extra wiggle room in those bolt holes. But look at the clearance in there. That is 1/16 of an inch all the way around. Absolute perfection. That's what that looks like in there. And the top. So we still have to mount our ESC, so nothing's permanent on here yet. Everything's just snugged up so we can see what it looks like. But this Falcon stuff, man, is top notch. It is super lightweight, super good quality. I absolutely love it. The fit, the finish, everything is perfect. They come balanced, so you don't even have to deal with that. Balanced perfectly. But so there it is. There's the mount of our prop. So here is my StinGR85 setup from HV Aviation. I am running, and my choice of motors on this was a 5858 PMAX motor from ProModeler. So John Beach runs ProModeler. I wish you guys would go over to his site and check it out, ProModeler.com. All right, this guy specializes in electronics, servos, motors, things like that. So what's cool about the ProModeler? Number one, this is a 12-tooth stator in this thing. This is a hand-wound motor. Since you really can't get machines to wind like this is a single strand 520 kV motor. This thing has the potential output, if I remember in this thing, of 4,800 kV. So this ought to be a 3D worthy motor all in itself. Like I said, hand wound, great pricing, ProModeler.com. Go check those guys out. All kinds of cool electronics there on their site, batteries, ESCs, motors, servos, you name it, ProModeler.com. Now, as far as the StinGR85 setup goes, that is from the man himself, Jim Kitt from HV Aviation. They have bigger than this. This thing is boasting an 11 to 12% efficiency over its full-size motor can counterpart. All right, so what does that mean for me? That means increased flight times and also reduced weight in this setup. Again, I'm not having my hands near the prop flipping. It's not finicky. You could fire this thing up first thing in the morning. But this thing uses a gear reduction belt drive system. And you know what the nice part is, guys? I don't have to understand all the science behind it. Jim has cataloged every piece of information and testing that you possibly need. Any motor combination, prop combination, ESC combination, he has it. I don't need to reinvent the wheel for this stuff. I simply tell him what I'm looking for and he gives me some options. And like I said, the guy's got a ton of information. If you're a guy that wants deeper, he'll go deeper. If you're a guy that just wants to scratch the surface and say, hey, give me a plug-and-play setup, he'll give you a plug-and-play setup for you too. Soldering the ends on, you know, getting ESCs mounted up, ready to go, you name it, he's the one that's going to give you the hookup. So here you guys can see the again, the motor that I chose, gear reduction setup, belt driven. We're actually going to modify this thing just a little bit, and this whole system, by the way, was introduced to me by a good friend of mine, Ronnie London. We talked over this thing immensely. I got a hold of this plane and I'm like, dude, this is the perfect project or blank canvas for this StinGR85 setup. Who do I get a hold of? So he guided me over to Jim, got a hold of Jim, and that's where this thing takes off. So again, gear reduction is where this thing really comes into play, into being efficient. KV in versus KV out. We're going to go ahead and anodize some of this stuff because my buddy Ronnie did it to his and it turned out phenomenal, and I think it will add a really nice touch to this plane because there's so many pieces here that we're going to you know, want to pop and be special. So we're definitely going to take this apart and modify it a little bit. But as far as weight goes, let's go ahead and check the weight on this thing. And I am going to take this over to, let's take it over to pounds and ounces with the ESC on it. And we'll even give the wire. So right there, 3 pounds, 1.9 ounces. That's pretty light. Think about it. Cost-wise, you're probably in the ballpark, depending what motor you go with a internal combustion or an ICE engine, if you will. But then you have to buy, you know, servos to operate that thing. And if it has a throttle and a choke, you're into 2 servos in there. And a lot of people, one of the mistakes that they make is they chimp out or cheap out on servos to operate the throttle. You should have a good high quality servo on that throttle. If you put good quality servos in the rest of the plane, I just match it. Especially you want one that's going to be fast, and depending on where your linkage is, you know, good torque is always there too. And then you're going to run one on the choke. So you could have 1 to 2 servos, all the linkage for it. You have to buy the motor, you have to buy the you have to buy the motor, you have to buy the muffler. Then in some cases, standoffs and mounts. Everything is here in the Stinger and it's ready to go. We have to just drop this thing in at a little over 3 pounds. Man, it's kind of impressive. Power to weight ratio, 2.4 to 1 on this plane. This plane in this setup, the Stinger 85, is capable with setup, depending where you go with it, roughly 42 pounds of thrust. It's pretty remarkable on a 25.5 by 13 prop. So if you haven't gotten over to HV Aviation yet, get there. HV Aviation on Facebook. Hit up the man by the name of Jim Kitt. Look him up. He'll help you out. Guys, hook yourself up with one of these systems. So far, I have been super stoked with this thing. The only downfall is I can't get this plane going quick enough. I'm impatient. Captain Impatient, right? We got to get going.